Okay, we're going to finish up chapter 10 today out of the book. So we're going to do the last two sections, section 7 and section 8. The first part is about independent and dependent variables. Hopefully you remember this from science. Independent is two things that don't relate to each other at all. Dependent means it's kind of like when you have an x and a y. Dependent's the y, so the x value totally determines what the y is going to be. So if we look at letter A, are the results of flipping a coin and rolling a dice independent or dependent? That would be independent. It does not matter what we get on the coin because the number cube, the die, will give us something completely different. A box is filled with a mixture of jelly beans. You pick one, you keep it, and then your friend picks one. So since you're picking one and then you're keeping it, those would depend on each other. Because if there was like 100 jelly beans in there, you have 100 choices, your friend only has 99. A coin is flipped, and then his coin is flipped again. That is independent. It really does not matter what the first flip is. The second flip is independent of the first. All right, if we do flip a coin twice, this is called a tree diagram. You can just put like heads or tails. You don't have to write the whole word out. So we have 4 possible outcomes if we flip a coin twice. Heads, 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 tails, tails, heads, or tails, tails. Each probability is half. We have a 50-50 chance of getting heads or tails. So heads, heads is a 25% probability. You could also think of that as 1 out of the 4 sample space. Heads, tails, and tails, heads are each 1/4, and tails, tails again is 1/4. So each one is 1/4. Okay, so in our next problem, we have the spinner. As you can see, red, you have a 1/2 chance of getting, whereas green and blue, you each have a 1/4. So the first question says, what's the probability of spinning 2 reds in a row? And that would be 1/2 times 1/2. The first probability times the second probability. So that probability answer is a 1/4. Probability of a spinning green and then a blue. Well, the green, how about if I make this green, is a 1/4, and the blue is also a 1/4. Whoa. And the blue is also a 1/4. So a 1/4 times a 1/4 is 1/16. So the probability of getting green and then blue is 1 out of 16. Red then blue would be 1/2 times a 1/4. So that answer would be an 1/8. And 2 greens in a row would be a 1/4 and a 1/4. 3 in a row and another 1/4. Which would be 1/64. So now we have 4 cards. What's the probability that you will pick the ace of diamonds? That would be 1/4. And that your friend will pick the ace of spades. Well, the question is, there's actually 2 different probabilities. The question is, are you putting the card back, replacing the card, or are you holding the card and is your friend then picking a card? If we think about this with replacement, it would be 1/4, then you put your ace of diamonds back, and then your friend picks the ace of spades. That'd be another 1/4. Each card has a 1/4 possibility of getting drawn because there's 4. So with replacement would be 1/16. Without replacement, would mean you pick your card, which is 1/4. You're holding your card, so now your friend only has 3 cards to pick from. So that would be a 1/3, and then that probability is 1/12. 2 different situations. So the next question is, what's the probability that I will pick a red ace and my friend will pick a black ace? Well, a red ace is a 1/2 probability. Again, are you holding the red ace or putting it back? So there's two different situations. With replacement, that means you put it back, then the black ace is a 1/2 probability. So that would be a 1/4. Without replacement, you have your 1/2 red ace. You're holding your red ace. So there's 3 cards left. 2 of the 3 cards are black aces. So it will be 1/2 times 2/3, which multiplies to give you 1/3. So if 2 things are independent of each other, you're going to do the probability of A times the probability of B, and that is when we replaced them, because that would be independent. If 2 things are dependent of each other, that would be when we held the card and did not replace. Then you do the probability of A, and then your new probability. Next up is combinations and permutations. So in combinations, order does not matter. And in permutations, order matters. That means, for this situation, you can choose steak or vegetable lasagna. You can choose rice, potatoes, or garlic bread, and then you can choose pie or cake. It doesn't matter if I pick my dessert first or last. Whatever the 3 things I have are the same no matter what order. So this situation is a combination. So I'm going to make a tree diagram here. My first choice is going to be for my main dish. And it doesn't have to be. You can do any of them your first choice. So I'm going to either pick steak or vegetarian lasagna. My second choice is going to be my side. So this is showing that I'm picking rice, potatoes, or garlic bread. So I could also have vegetarian lasagna with rice, potatoes, or garlic bread. And then my third choice is dessert. If I have steak and rice, I could either have pie or cake. If I have steak and potatoes, I could either have pie or cake. And if I have steak or garlic bread, I could either have pie or cake. So right here, I have steak, rice, pie, steak, rice, cake, steak, potatoes, pie, steak, potatoes, cake, steak, garlic bread pie, steak, garlic bread, cake. And then the same exact thing goes down here for vegetarian lasagna. I either have pie or cake. So again, vegetarian lasagna with rice and pie, vegetarian rice and cake. Vegetarian potato pie, vegetarian potato cake. Vegetarian garlic bread pie, vegetarian garlic bread cake. So my total options here are 1, 2, 3, 4, 5, 6, 12. I can also get that number by thinking about, I have 3 different choices. The first choice, I have 2 options, steak or vegetarian. The second choice, I have 3 options, rice, potatoes, or garlic bread. And the third choice, I have 2 options again, pie or cake. 2 times 3 times 2 is also 12. This gives me a detailed list right here of all of my options. So if I do have to do probability, I can look at the exact options. Okay, a voicemail system. Password is 2 letters followed by 2 digits. So the 2 letters are there's 26 letters in the alphabet. And there's 10 numerical digits, 0 through 9. So if I multiply this out, I get 67,600. So a password with 2 numbers and 2 digits has 67,600 different options. If I had to find the probability of like A, B, 1, 2, that would be 1 out of the 67,600 options. So a simple event is a single outcome, so like rolling a 4 on a dice or flipping a coin or spinning a spinner. A compound event is 2 or more simple events, so that'd be like rolling a dice and flipping a coin, or spinning a spinner twice, or choosing dinner options of chicken, rice, and pie. And then again, combination is where the order doesn't matter, and permutation is where it does. So if you were, stringing a cubical, spherical, and cylindrical bead on a necklace, the design would look totally different if you did those 3 beads in a row. Or if you were picking someone for president, vice president, and treasurer, the 3 order would completely matter, because if the first person is president and they want to be treasurer, that's not the same. So how many different ways can the numbers 1 through 9 be placed in a row of a Sudoku puzzle? Well, in the first spot, we have 9 options, because we have 1, 2, 3, 4, 5, 6, 7, 8, or 9. And then the second spot, one of the numbers is taken, so we have 8. The third spot, one of the numbers is taken, so we have 7, and so on. This is also called something special. It's called factorial. So there's an exclamation point in math, and that means 9 times everything below. So if we had like 3 factorial, it would be 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. There is a button on the graphing calculator, and it's on some scientific calculators too. You have to go to the math button if you have a graphing calculator at home. And then you go over 3 times to the title of probability. And then you go down to number 4, and that's your factorial button. The problem is you have to put the number in first. So I would put 9, and then I would do all of this stuff. So 9 factorial in the calculator is 362,880. So that's how many different ways there are to do a Sudoku puzzle. That's completely blank. So 3 factorial is 3 times 2 times 1, which is 6. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. 1 factorial is just 1. 0 factorial is 0. So the next question says, how many ways can 3 people stand in line? So if there's 3 different spots, the first spot has 3 options. One of the options is now taken, so the second spot has 2 options, and the last person would be last. So 3 times 2 times 1 is 6. If you want a detailed list of those things, we could do like A, B, and C. And then you would have the second person, and then you would have the third person. So it could be ABC, ACB, BAC, BCA, CAB, or CBA. So that's kind of like the president, vice president, treasurer. And then it says, how many different ways can you arrange the words math? Well, there's 4 letters, so there's 4 options for the first space, 3 for the next, 2 for the next, 1 for the last. When you multiply that or put it in your calculator with the factorial button, you get 24. Alright, so now we're going to have 6 beads, red, blue, yellow, green, black, and orange. How many different ways can you string 4 of these beads? So we don't have 6 spaces, we only have 4 spaces. So the first space we have 6 options, second space we have 5 options, third space we have 4 options, and the fourth space we have 3 options. So this is not a simple factorial. This is 6 times 5 times 4 times 3. We could rewrite this with factorials if you divide by 2 factorial, because that would get rid of the 2 and the 1. Whoops. So this formula is called permutation, where order matters, and it's written like this, and n is the number of choices that you have, and R is the number that you're choosing. So in the last problem with the 6 beads, it would have been 6 factorial over 6 minus 4 factorial. That's where that 2 factorial came from. And that's the answer. So next we have 8 swimmers. Prizes are given for first, second, and third place. So this time we're going to do a permutation. We have 8 swimmers, so there's 8 different options, but we're only giving prizes to 3 spaces. So we have 8 factorial over 8 minus 3 factorial. That's 8 factorial divided by 5 factorial, which is 8 times 7 times 6. That answer is 336. Four jelly beans in a bowl. How many different combinations can you make? So with 3 flavors. Okay, we have combination, where order does not matter, because it doesn't matter what 3 jelly beans you get. The permutations are below. So to calculate a combination, it's a little bit different, because ABC would be the same as BAC, which would be the same as CAB, which would be the same as CBA, which is the same as BCA, which is the same as ACB. So we have to get rid of these doubles. So we need to get rid of all these doubles. This is called a combination, and this pattern equation is this. Again, n is the number that you're choosing. Again, n is the number of choices that you have, and r is the number that you're choosing. And we have this extra r factorial down here, and that's what's going to get rid of all the doubles. So in the last problem, we had 4 Jelly Bellies, so that would be a combination with 4, and we're picking 3 different flavors. So we would have 4 factorial over 3 factorial times 4 minus 3 factorial. So 4 factorial over 3 factorial times 1 factorial would be 4. The next problem says 4 people need to be selected from a class of 15. So it doesn't matter the order. So the combination is 15 possible people for being selected. So we're going to do 15 factorial divided by 4 factorial times 15 minus 4 factorial. So that's 15 factorial over 4 factorial times 11 factorial. Well, the first thing I do is look at the 15 and the 11, because that's really just 15 times 14 times 13 times 12, because everything else is going to cancel with the 11 factorial. And then I still need to take into consideration the 4 factorial. So my answer is 1,365.